Let me show you how to interact with a Kubernetes cluster using KUBECTL. It's the command line tool that lets you interact with your Kubernetes cluster. First, we need to set it up on your machine. Assume you have a Mac system, use brew install KUBECTL. Once installed, check if it's working using the command KUBECTL version client. To connect to the cluster, get the kubeconfig file from your admin or cloud provider. Place it in the home/.kuba directory like this. There are two approaches to interact with the Kubernetes API server to manage resources. The first way is the imperative approach, where you just run commands to get things done. Like, if you want to create a deployment, you can use the command KUBECTL create deployment, then your deployment name and parameters. For more details, you can go with the declarative approach. Here, you define everything in a YAML file and let Kubernetes handle it. For example, you'd create a YAML file for a deployment and then tell Kubernetes to apply it with the apply command. Let me first show you the CRUD commands you can use with the imperative approach, like create, get, edit, and delete. Plus, you've got debug commands like logs and exec to check what's going on inside your pods. Let me start by showing you how to create a resource using the create command. For example, let's say you want to deploy an Nginx server. Let's create a deployment for an Nginx server. Run the following command. This will set up a deployment named Nginx DEP. Kubernetes will automatically pull the Nginx image from Docker Hub. If one pod isn't enough to handle all requests, you can scale it up to 2 replicas. This will create an additional pod, so you'll have 2 replicas handling the traffic. Now, let me show you how to use the get command. If you want to see details about the components in the cluster, you can run KUBECTL get resource type. For example, let's see how to get the details of deployments in the cluster. You just run this command, KUBECTL get deployments. Here's what the output means. Name, the name of the deployment is Nginx DEP. Ready, it shows how many pods are ready versus how many are desired. Here, 2 out of 2 pods are ready. Up-to date, the number of replicas updated to the latest version. All 2 replicas are up to date. Available, the number of replicas available to handle traffic. Both replicas are available. Age, how long the deployment has been running. Now, let's say you want more details about the pods created by your deployment. You can use this command. Here's what it tells you. Name, each pod has a unique name. Ready shows how many containers in the pod are running versus how many are expected. Here, both pods are fully ready. Status indicates the current status, which is running for both pods. Restarts shows how many times the pods have been restarted. Both are at 0, so they've been stable. The IP address of each pod can be returned, but not directly with the basic KUBECTL get pods command. You need to include the O-wide flag to see additional details, including the pod IPs. To make changes to an existing resource, you can use the edit command. It opens the resource's configuration YAML file in your default editor, so you can modify it directly. For example, if you want to edit a deployment called Nginx DEP, you'd run KUBECTL edit deployment Nginx DEP. Once you make the changes and save the file, Kubernetes will automatically apply them to the resource. Let's go back to the case where there are 2 pods to demonstrate the delete command. Since there aren't many users this month, let me delete one of the pods. You can do it by running KUBECTL delete pod, then the like this. This will delete the pod with the ID Nginx DEP pod _ID_2. Let me give you another example for deleting a deployment. Let's say this app is deprecated, so I'll delete the entire deployment. You can do it with the command kubectl delete deployment. For example, to delete the nginx.dep deployment, you'd run kubectl delete deployment nginx.dep. This will delete the entire deployment. Now, let's move to the second approach, declarative, where you define the resource in a YAML file. This file describes the resource's configuration, such as its type, name, replicas, and more. Once the YAML is ready, you apply it to the cluster, and Kubernetes creates or updates the resource accordingly. Let me create a deployment using a YAML file as an example. Here's what the file might look like. To apply this deployment, you'd save it as nginxdeploy.yaml and run kubectl apply f deployment.yaml. Let me first show you how the YAML file looks. The first part, API version, specifies the version of the Kubernetes API that the resource belongs to. It tells Kubernetes which API version to use to process and manage the resource. The next part is kind, which specifies the type of resource you want to create or manage. For example, kind deployment tells Kubernetes that this YAML file defines a deployment resource. The next part is metadata, where you must include the name to uniquely identify the resource. Optional fields include namespace, which specifies where the resource is located, and labels, used to categorize and group resources. The next part is spec, which defines the desired state and configuration of the resource. Its content differs based on the type of resource being defined. For example, in a deployment, you can specify replicas, which defines the number of pod replicas you want Kubernetes to maintain. And the template, which defines the metadata and specifies the spec for each pod created by the deployment. For each pod, you must specify the image, which defines what will run inside the pod. What's interesting here is that the labels section helps group related objects. For example, in this case, the label app, Nginx is added to each pod, making it easier to identify and manage them as a group. These labels also help connect the pods to the deployment through the selector section, which ensures the pods match the same labels.